So following on from the previous video, we got to this stage here. We got to this stage here. We got to this stage here where this is exactly the same as this, but just written differently. The good thing about it is that we've got our x minus 2. The good thing is that we've got our x minus 2, our x minus 2. But the thing is, in order for us to make use of this, we need it in the form of 1 over 1 plus a bubble. But here we've got a 3. So what we do is we factor out the 3. So it looks like this. Factor out the 3. So that will then become this 1 and then plus x minus 2 over 3. So now if you get this times this and then this times this, it will then give you this thing here. So this is exactly the same as this. Okay, so now you've got 1 1 bubble. So now you've got 1 1 bubble. So now you can make use of that series. You couldn't do it up here because you need 1 1. You need this to be the 1. So rewrite it as this. So now you've got 1 1 and then plus the bubble. So now we can make use of this series because we've got hang on, bear with me. Because we've got 1 1 bubble, so we can make use of this thing here. So rewrite it in this form. So now that will then take us to here. So hang on, bear with me. Let me just move this across. So now we've got 1 1 and a bubble. So this bit here we can make use of this. So leave this third alone, and then just blindly make use of this series here. So this will then generate this. So here you've got minus. You've got minus bubble. So this is our bubble here. So this is our bubble here, and then you've got plus, and then our bubble. This is our bubble here. This is our bubble here, and then you've got to square it, and then minus bubble to the power 3. Bubble to the power 3. That will then give us this. So now multiply this out. This times this. This times this. So this times this will then give you a third. This times this will then give you this. This times this will then give you this, and so on. So now this is our Taylor series. We've just obtained our Taylor series, because if you look at this here, this is x minus 2 to the power of 1, if you like, and then this is x to the power of 2. Sorry, this is x minus 2 to the power of 2 to the power of 2. X minus 2 to the power of 3 to the power of 3. So this is your coefficient here. This is your coefficient here, and so on. You see, by making use of this, it's much quicker to obtain our Taylor series. So this is our Taylor series for 1 over 1 plus x evaluated, well, centered at 2. So what that means is, if you get a graph plotter and plot this, if you get a graph plotter and plot it, it will give you this blue line. You notice, so what you notice that the purple line. The purple line will now map on top of the red line. It is a red line that we're interested in, not the green one. So what's happening is that we start out with our general power series, apply this transformation. We move everything across by 2. So now our general series centered at 0, and then make the demand that the first derivative to match up with the first derivative, second derivative, and so on. And then this thing here will slowly map on top of the red line, as opposed to the green line. The green line, we are not interested in the green line. So now the purple line will map on top of the red line. So this is our Taylor series. Now we need to look at the domain for our function. So if you look at this here, for this one here, we require the absolute value of the bubble, the absolute value of the bubble, to be less than 1 in order for this series to be valid. So let me think. So now we need this bubble here. We need this bubble here to be the absolute of that to be less than 1. So we need the absolute value of this bubble to be less than 1. for convergence. So now whenever you see this absolute less than 1, you can always translate it as this. So now times everything by 3, that will then give you this, and then and then add everything by 2, that will then give you this. So so our Taylor series is valid in between -1 and 5. So what that means is this is our Taylor series here. If you take it all the way to infinity, it will get very close to this red line here. But remember, it's valid from where to where? Hang on, let me think. From I think it was from -1 to 5. So from -1 to 5. Hang on. From -1. So this is -1 here to 5, which is around here. Remember, strictly greater than -1. So so it's valid in this area here. It's valid in this area here. Okay.